So threads in Java, we have taken this scenario in the last class. What is that scenario? File handling scenario we have taken up, right? That is, you have two separate files. To each file, you have to write integers from 1 to 100 and 101 to 200. Say to file 1, I'm going to write what? Integers 1 to 100, and to file 2, I'm going to write integers 101 to 200. So we have taken up this exercise. I went and I completed the code for that. So here I am writing to file 1 using a file output stream, writing 100 from 1 to 100. So it's 1 to less than equal to 100, and this is actually 101 to 200. Okay. So we are going to write these two things to two separate files. You take a look at this code, writing to file 1, file output stream, writing from 1 to 100 to file 1, again opening file 2, an output stream, writing from 101 to 200 to file 2. So let's run this one. Let's check whether this is working. Yeah, that is working. We also have the files created. Let me go to the place where we have the files. So when I take a look at file 1, so whatever characters, the integers I'm writing will be mapped to a character set, and then it will be written to the file. We're not worried about what is getting written to the file. The only question we have here is, when we analyze this program, what is happening? First, it's writing data to file 1. This activity should complete. Only then it will write data to file 2. But for file 1, we are writing separate set of data. File 2, we are writing separate set of data. Why should this write wait until this one completes? Can we really make things happen parallelly inside a program? That is the question. Can parts of a program be run parallelly, simultaneously? So what are the two parts we want to run simultaneously here? Yeah, some analysis. We want to write this part, writing to file 1 and file 2. These two blocks should run parallelly. So this block should be an independent path of execution, writing to file 1. This one should be totally independent from this one. So we have two independent paths that we are going to create that will execute and complete. So how do we create this parts in a program that can run concurrently? We have to use the concept of threads. So what is this thread? Thread is nothing but a class in Java. There's a thread class in Java. Whenever you want to make a certain part to run concurrently, what you have to do is, you have to extend this class, and inside this class you have this run method. You have to just override that run method in your code. So thread class we are going to use to create threads and make things work parallelly. We'll see that. So what is the thread? Thread is an independent path of execution within a program. Many threads can run concurrently within a program. All Java programs have at least one thread. Main is also a thread. It has its own independent path of execution, starting from the beginning, first line, it'll just go to the end, right? So main is also one thread. So how do you create threads is the question. To create a thread, the very important thing is, you have this class called thread class in Java. Say this is the code for thread class, and you have to go and extend this class. So I'll just show you how to create two threads for running file 1 and file 2. Okay. So let me go and create that. So what I'm going to show you is how to make these two things run parallelly. For that, the very first thing we have to do is, we have to extend the thread class. So how many parts of code I'm going to run parallelly? Two parts. For each part, you extend this thread class. So class process file 1 extends thread. That is for file 1, right? And inside this thread, you'll have this run method that you're going to override. How will you override? You just go override implement methods. So you just go and give run. That's it. We are just going to copy paste the code for writing to file 1. What is the code for writing to file 1? Open the file, write the file, close the file. So just cut this one, paste it inside the run method. Very simple. So it will ask you for some exception handling things. That's default in Eclipse. So we'll just copy paste exception handling. We're just having some try and catch blocks here, nothing to worry. And okay. So what I have done, writing to file 1 I have pasted here. Now file 2 also should be running parallelly, right? So what we'll do is we'll create a class for writing to file 2. How will you create a class? Class process file 2 extend C, everything that runs parallelly should extend thread. And then what you have to do in process file 2, again you have to override this run method. So you just click on this override run method. And inside this, what you are going to do? Whatever that should be running parallelly. What is this? Writing to file 2, right? So just copy this and then put it inside this one. And obviously it's going to ask you for some try catch blocks. I'm just surrounding it with some try catch blocks here and there, nothing to worry. So this is surrounded by a try catch block. So what I have done is writing to file 1 in one class under the run method, writing to file 2 in another class under the run method. So that is our first step. Next step is we have to create an object of these two classes. So how will you create an object of these two classes? New, and then say it is process file 1. That is my first class. So I am creating an object for that. Let's say it's file 1 and then new process file 1. So like that you create an object for file 2 to process file. What is that? It's process file 2. So file 2 and then is equal to new process file 2, right? Create two objects. Next what you are going to do here, you have to start the thread. So how will you start the thread? Give the file object name file1 dot start. So start is the method in the thread class which will start a thread. Likewise file2 dot start. So now what happens when I do file1 dot start, the code inside the run method will start running. Now it will run parallelly. Likewise file2 dot start will be separately independently executing parallelly with file1. So both these things will run as a thread simultaneously. It's not writing to file1 and then writing to file2. So we'll see that. So what we'll do is we'll have some, say wherever I'm writing to file1, inside this for loop I'll have a sysout statement saying file1 write. Okay. Likewise here in the next class wherever I'm writing to file2, I'll have a sysout statement just for a reference, this is file2 write. It's nothing like that. These two things are totally independent pieces. So now whatever, there will be a scheduler that will be running your threads. You'll be taking the thread, assigning it to the processor. So which one is getting assigned depends on the priority of the thread. So we'll come to all these concepts in a few minutes. Only thing I want to show you is it will not be just like this, writing to file 1 and writing to file 2. We'll execute this output and see what's happening here. So you see here, you can see a very clear distinction here. File 2 write, file 1 write, file 2 write. There is an interleaving of file 2 and file 1. It's not completing file 1 and then going to file 2. It's not completing file 2 and going to file 1. So what happens is, maybe some writes are happening for file 1, then switches to file 2, writes some writes. Say there are certain waiting times, right? There are some IO times. You're fetching data from the hard disk and then you're writing data to the hard disk, things like that. So when there is a waiting time, it will switch between tasks too. So here, this is called running things parallelly, parts of a program running parallelly using threads. So what are the steps? You have to extend the thread class, put whatever code that you want to run parallelly inside the run method, and then create an object for each class that you have created here, extended. So it is object for this, and then object dot start. Dot start will start your thread. So That's about it. Before even going further, how do we create threads? We have two different ways of creating threads. One is by extending the thread class. The another method is using a runnable interface. There is an interface by name runnable. So we are going to implement that and also create a thread. We'll see that in the next slide. So creating a thread, this is what we have seen. So extend the thread class, put the code inside the run method. Next, you extend the thread class for writing to file 2, put the code inside the thread method. It's going to work parallelly when you create objects and you start the threads. It's object name dot start and not dot run. Don't confuse it. So I have given a screenshot to say it's running parallel. So how did we create this thread class? When you take a look at this, here we are creating an instance of type thread, right? We are extending thread and we are creating an instance of that. So this is the first way wherein we don't give any parameters to our class. For instance, how do you create thread? So thread has got many constructors. The first constructor is the normal way, like what we have done. The second constructor is you can pass a thread name. For every thread, you can give a name to it. Say, let me go back. But this name, when you take a look at name, it is actually part of the thread class and it is a private array. So when you take a look at this, it's a private character array. It's private. And how you initialize this character array? You will be using this constructor in the thread class. That is the base class. So if you are extending it and then you are giving a string name, what you normally do? From the base class, you have to pass it to the super class using super keyword. So this we have been doing continuously in our exception handling too, right? So what I will do is I will create a thread with a thread name now. So how do you create a thread with a thread name? So process file 1, I can give a thread name to this. Say I'll give Satish thread and another thread name Satish 2 thread, something like that. What you can do here is now this name should be passed to your base class. That is the thread class. How will you pass that? You can have a constructor in your class process file. So you go and have a constructor there. And whatever information that is coming in, Satish thread, right? That's a string of type string s. And then how will you pass it to your base class? You just use super and then pass that. So now this will be passed as to the super class as a thread name. So you given a name for the thread. Likewise for our process file write to, we have given a name, right? How will you pass it to the base class? So you get that string whatever we are giving in string s and then you pass it as super to, that's it. So now we have created a thread name, right? So how can we view the thread name? You can give a sysout statement and then say I want to view the thread name. I can give file1 dot get name. So you're using this object dot get name will give me the thread name for that particular thread that's running. So like that I want to view the thread name for another thread too. So I can give that. So it's file2 dot get name. So if I go and print this one out, am I getting the thread names out? It will be in the very start, I guess. Satish thread and Satish2 thread. See again, you see these two things are not printed at the end because main thread is running. It'll start this thread and it will start to continue further. This thread will be running independently writing to file 1. That thread will be running to file 2. Main thread. So there are 3 threads here. Main is also a thread. All these 3 things run parallelly. Got it? So we know how to create threads by giving us thread name. What is this? Thread name. The third method is passing a runnable target. That is, you create an object of type runnable and then you pass it to your constructor. What is this runnable? Runnable is nothing but an interface. I'm going to use only runnable in all my thread creations. So it's runnable is nothing but an interface. What is an interface? All the methods are abstract. You don't have any definition for the methods. When you implement this interface, you have to provide the implementation for the abstract methods. So what is this runnable interface doing here? No, we'll just go to the runnable interface. Runnable, right? So let's check what is this runnable in Java. Okay. Let's see the implementation for runnable. So when you take a look at runnable, it's an interface, and the only method it has got is void run, nothing else inside this. So if you have some code that runs parallelly, implement this interface and then put that inside the run method. So I'll go and show you an example how to create threads using runnable. So let me not have all these things. Let me delete a lot of things from my code. I'll be switching over to simple examples rather than staying with files because the code becomes very big, difficult to understand too. Let's take some very simple examples and let's try to understand. Whenever I have something that should run parallel, what I should do is I should create a class. Say test is the class. Now it implements runnable. It's not extending thread, implements runnable. Next, what we are going to do, when you implement this interface, provide the implementation for the run method. So how will you provide the implementation? Just go and say override implement methods. So you have this run method, click OK. Now, instead of doing some file operations, I'll give a sysout statement here. Say I am from the thread, something like this. So something here should run parallelly. That's it. And how will I create a thread using this particular object that implements runnable? That is the question. So what I should do is first I should create an object of type test. So I will create an object of type test. You have this test and then you give t new test. So I created an object of type test. It is implementing runnable. Next I have to create thread class, create an object of type thread thr. Thread is the thread class is equal to new thread. And then inside this, you have to pass the object of type runnable, right? That is T. So what is this meaning? This means passing object of type runnable. So once when you are done with this, how will you start the thread? You just do thr, that is this thr, because you have created a thread here, thr dot start. Very important. After you create this object, you should also create an object for thread because only thread class has got start method. Runnable interface has got only run method. Got it? So that's why we are passing it here. Let's go and check whether this one works. So threads dot start. So it should print me that I am from the thread message. Like that, you can create any number of threads inside your program. Each one will run parallel to each other. Are you all clear how to use runnable and create the thread? I'm going to tweak this one too. I'm not going to every time create an object and pass it here. So just to create this object and use the run method, I'm having this class, right? Just for this run method, I'm creating a class. So I'm going to use an anonymous class, a class without a name. Instead of creating class test implements runnable, I'm just going to directly use that inside my thread object instantiation. I'll show you how to use an anonymous class. Say I don't want to write a class just for the run method. I don't want to perform this. What I can do, I'll have this thread. Now inside this, what I want is, I want a new runnable object. I'm just creating a runnable object here. It's of an object of type runnable, but without any name like test or best or rest. And you have this run method, directly go and give whatever code you want to run it parallelly here. So this is sysout, I am from the thread. So we call this thread 1. I am from thread 1. Then Say instead of creating a class, implements runnable, and then creating an object for the class and passing it here, directly create a runnable object, put whatever code you want inside that run method, finish. So this code will run parallelly. If I want to create another thread, how will I create that? So again I should go and create another instance of thread. Thread thr2, thread 2 is equal to new thread, and then inside this I'm going to have a new object of type runnable, and so inside this run method I'm going to put my code. Say what code is this? This is for my second thread, so I'll say I am from thread 2. Two threads I have created. Main is the third thread. So in the third thread, the main thread, I'll have a sysout message, that is I am from the main thread. Okay. So we have to close this quotes. Now we'll run this. So this will run parallelly, this will run parallelly, and this will also run parallelly. So three things running independently, independent parts of execution. Let's go and check this one out. Oh my god, some error is there. Where is that error? This one is an additional parenthesis. Yeah. So what is that we are missing here? Thread 2 dot start. See, we have not started thread 2. So thread 1 was running, main thread was running. So how will you start the thread 2? It's very easy, right? thr2 dot start. So you have started all the threads, everything runs parallelly. Let's check the output. So I am from thread 1, main thread, I am from thread 2. There is no sequence here. Okay, let me move forward. So this is another variation. You can also pass this object and also give a string name for your thread, that is thread name. There are many other constructors for your thread class. I'm not going to explore all those things. These four constructors are fine. Using runnable, we have seen all these things now. So which method I should follow? Should I extend the thread class first method, or should I pass the runnable object as the parameterized constructor? Which one is most preferable? They say runnable. Implementing runnable and passing it as a constructor is the most preferred way of running something parallelly. That's because here you're not extending anything in your class. Class, process, file, write, extend thread. You cannot have multiple extends in a class, right? So you're limiting it. But when you perform it this way, you're not extending the thread class. So you always have the option of extending some other class in your class. So that's the only difference I found out through all my research. So both these ways are fine, but runnable is the most preferred way. I too like runnable using the anonymous class declaration. Memory allocation for threads. So we say everything is running parallelly. How memory gets allocated for threads? So I have a thread here, class test extends thread. Inside this I have the run method. Run method is calling add method. So from run I am calling another method in my class, add method. Add method has some variables. It calls the result method. So from run you call add, from add you call result. Each method has got some variables. So what happens here is, for every method, say for run, you have a stack frame created. This is the stack memory. You have a stack frame created for every method. Say for run method, you have a frame and you have some variables allocated. So some area on the, where is this allocated? On the stack memory. You know Java has this heap on the stack memory, right? On the stack memory, for every thread, there is this stack frame. For every thread, you'll have this stack frame. So when this method calls another method, this frame gets pushed on top of the stack. This method calls result method, so it gets pushed on the top of the stack. So result method completes, returns back the call to add method. So this will go out of scope. Then this completes, gets the call back. So this goes out of scope. So you have a stack created on the stack memory in Java for every thread. Say if I have 4 threads, For each thread, there will be a stack created on your stack memory. And this is the private stack memory. Another thread cannot access this particular stack. So I have this function get stack trace. For a thread, I can get stack trace in the sense it will print me all the methods called from run method. So I'll share this slide with you. Maybe you can go and execute this code. You can see it will print the stack trace, run, add method, result method. Like that for every thread, you can also print the stack trace. So heap and stack memory area. So in your stack memory area for every thread, you'll have a separate stack created. And say if you have an object created inside your method, one of your methods, where this memory will be for this object. So this uses the new operator. So this reference will be on the stack, but the object will be on the heap. So with this understanding, what we'll do is we'll go to our next concept, how threads get executed by the processor. So there are many threads in my program. Say I have 4 different threads created and all these threads are running. So how it gets allocated to my processor? Which thread gets the importance? How it goes to the processor? Who goes in first and gets executed? So what happens here is we have a thread scheduler in Java. So we have a separate thread scheduler. What this guy does is it will be waiting for threads. So threads come in with some priority. Priority is a number. Say for this thread I am giving a number 10, for this thread number 5, for this thread number 1 and for this thread number 5. So what is this number? Who is defining this number? It's predefined in Java. A thread can get a number between 1 to 10. 10 is the highest priority, 1 is the lowest priority. You cannot go beyond these numbers. So when threads come in with an highest priority, immediately that guy will be given the processor to complete because he has the highest priority. For any thread that you create, the normal priority that is assigned is 5 by default. And 1 is of lowest priority, so that will be going in at the end. Say if a thread is executing and then an high priority thread comes in, then this thread will be preempted from the processor and then high priority thread will be given the processor. So what this algorithm is called preemptive priority scheduling. Based on the priority, I will assign some time slice inside my processor. So every thread will run for certain time period and then it will be preempted. One important thing is if 2 threads come with the same priority, I am also priority 5, another thread is also priority 5, then who should go to the processor? First come first serve basis. So whoever comes on time first will be given the processor. Again, there is a time slicing concept here too. A thread cannot run forever inside the processor blocking all the threads, then that will lead to starvation of the threads. So what happens is you give a time slice and then you preempt the thread, assign the next high priority thread. So there can be a question, if 2 threads come on the same time with the same priority, there is an arbitrary choice happening within the scheduler that is not known to us. One of the threads will be selected. So thread scheduler is playing the role on assigning processor time. So you are saying some file 1 writes, then file 2 writes, some file 1 writes. So there is a mix up of things, right? That happens because of the thread scheduler who is assigning things out. So now the question is, can we define priority for a thread? Yes, we can set priorities. I can say this thread I have created is priority 1. Another thread is priority 10. So we can do that. We can take a look at the thread class quickly. Let's look at this word priority. Where is this priority? Is it defined? Yeah. Set priority. So this method we are going to set priority here. But where is this max priority? I am not able to see this. Yeah. When you take a look at this class, minimum priority is 1. These are static final variables. You can't change them. Normal priority is 5. Maximum priority is 10. Static final variables declared. Why they are using this is You can go and set priority for a thread. When you're setting this priority, it will check whether this is between min priority and max priority. If you set something like 12, it will say illegal argument exception will be thrown. You're passing something illegal there. So what we'll do now, we'll go and set priority for our threads. How many threads we created? We created some 2 threads, right? So let me set some priority. Say thr1 dot set priority is the function, and I can give a number 10. Okay, thread 1 is of priority 10, and I can give for my another thread 2 thr2 dot set priority. Say it's 1. I'm giving least priority for thread 1. For main thread, the default priority is 5. You have a main also to be a thread. So for main, the default priority is always 5. So what we'll do now is we'll go and execute. What is the output here? I am from thread 1, that is of priority 10, default priority 5 for the main thread. I am from thread 2, that is priority 1. So when you assign some priority, there's a maximum chance that that thread will get in first and execute. You can also have another method, that is get priority. So how will I set priority? You have this private int priority in your thread class. You can just go and do dot set priority and give a priority. It's a number between 1 to 10. There's another priority class, that is get priority, another method. It will return the priority that you have set for a thread. You want to know the priority, you can just do thr1 dot get priority. That's the priority. So it returns an integer value. That's it. There is this method currentThread. This will actually point to the current thread that is executing. When I inside my run method, if I do currentThread dot get name, it'll just print. It's a reference to the current thread that is executing. Say for instance, I want to print my main method's name. If I go here, I want to print my main method's name. What I can do is I can do thread dot currentThread dot get name. So this actually returns a string. Let me put that in the sysout message, and you can just put it here, sysout. So this thread dot current thread dot get name. So what is that that is executing currently? That is the main thread here. So it should print me the name for the main thread. Is there a name for our main thread? Let's go and execute it. Let's check what happens. Main. Okay. So this main is nothing but thread dot current thread dot get name. Okay. Am I too fast? Are you able to follow? We'll look at join and then we'll wind up for today's class. What is this join? Say I have 2 threads, thread 1 and thread 2, and many threads. We'll take many threads for an example. You will have thread 1, you will have thread 2, you will have thread 3, thread 4. So 4 different threads in my program. But there is one condition I want to meet. Thread 2 should run only after thread 1 completes. I have a dependency between my threads. Thread 2 should run only after thread 1 completes. I'm not worried about other threads, they can run parallelly. So what I will use is I'll use the join method. Join, when I say thread 1 dot join, the next step will execute only when this thread completes. Okay, so how will I use join? Join is a method, it waits for a thread to die. So when I do thr dot join, I call this method, until this thread dies, the next step will not execute. Only when this thread terminates, the next step will execute. So what we'll do is, we'll take again our multiple threads. We have some examples here. Say I want to perform this and show you. Say I want to print hello world and then thanks for using our software. 3 messages I want to print, but I want to print that in the order hello world, thanks for using our software. Everything as a thread. So first hello should complete, next world should complete, next thanks for using our software should run. I've taken a very simple, easy example here for quick understanding. You can think of any complex examples. So let me go and run this one. So what is my first thread is going to do? I'm going to say hello, and then I'm going to delete everything. That is my first thread. Next thread is it's going to say world. That's it. And then I'm going to come to my main thread. From the main thread, I'll say thanks for using our software. So from the main thread, I'll perform this. What is that? Thanks for using our software. Okay. Let me delete this one too. And let me delete this thread priority setting. So what I will do is I'll start thr1.start my thread 1. Next I will do thr1.join. So when I do thr1.join, it will ensure that thread 1 completes. Only then it will go to thread2.start. Then you do thread2.start. After thread 2 completes, so it's thread2.join. So it ensures that thread 2 completes and then main thread will complete. So if you don't have these two join methods, what will be the output? They comment the join and run. Will I get hello world and then thanks for using our software in the order? Somewhere there's an error. Okay, here 2 times I have closed the quotes. See, it's in the reverse way now. Thanks for using our software world hello. But I am forcing hello to complete first, next world, then finally our main thread. So how will I perform? So thread1.join will force thread1 to complete, thread2.join force thread2 to complete, and then why it's throwing an issue here. Add throws declaration, some Eclipse function signature should be added. That's fine. Now when you go and run this one out after join, hello completes first, next world, then thanks for using our software. So when you use thread.join, that thread should terminate. It should complete. Only then the next statement will execute.